Welcome to the channel, Singularity. Today we're diving into one of the coolest topics in space science, asteroid. Asteroid 99942. Apophis is about 375 meters, or 1,230 feet wide. Think 3 football fields or the Empire State Building. If it struck Earth, it wouldn't end life like the 10 to 15 kilometer dinosaur killer, but it could unleash over 1,000 megatons of TNT energy, tens to hundreds of times stronger than the biggest nuclear bombs. An impact could flatten hundreds of kilometers, trigger tsunamis if it hit water, and loft dust to mess with regional climate. The damage hinges on location. Cities or coasts would suffer more than deserts or forests. Near-Earth objects, or NEOs, orbit within 1.3 times the Earth-Sun distance, which is about 195 million kilometers. By March 2025, we've cataloged over 34,000, with about 2,000 labeled potentially hazardous asteroids, bigger than 140 meters and passing within 7.5 million kilometers of Earth. Millions of asteroids over 1 kilometer lurk in the asteroid belt, but only some cross our path. Weekly discoveries pile up via surveys like Catalina and NEOWISE, yet many smaller ones, like the sneaky asteroid 2019 OK, slip by unnoticed. The Torino scale ranks impact risk from 0, no threat, to 10, global doom. Most NEOs score 0. Apophis peaked at 4 in 2004, 2.7% chance for 2029 regional devastation, then dropped to 0 with better data, safe for 100-plus years. Today, only 2024 YR 4 scores above 0, a 1% chance of local damage in 2032, likely to downgrade with tracking. The scale's colors, white to red, simplify risks for the public. Tracking NEOs is tough. Their orbits wobble from planetary gravity. Apophis's 2029 flyby within 32,000 kilometers will stretch its path, shifting it from an A10 to Apollo asteroid. The Yarkovsky effect, sunlight heating one side, nudging it via heat emission, complicates things, especially for rubble piles like Apophis, where we don't fully know the makeup. Limited data means early predictions have big uncertainties. Apophis had a 2.7% impact chance in 2004. Asteroid 2019. OK stunned scientists. Smaller NEOs are dim and often invisible until they're close. Take Asteroid 2019. OK, a 57 to 130 meter rock that blindsided scientists in July 2019, spotted just 24 hours before zipping past at 73,000 kilometers, closer than 1/5 the lunar distance. Coming from the sun's direction, it dodged telescopes until the last second, a stark reminder of detection gaps. Detected by Brazilian and U.S. teams mere hours before its July 24, 2019 flyby, this football field-sized rock, about 187 to 427 feet, barreled in at 24 kilometers per second. NASA's Paul Chodas called it the largest known asteroid to pass so close in a century, twice a century rare. It wasn't on any watch list. Its elliptical orbit and sunward approach hid it until it was nearly here. Had it hit, it could have unleashed 10 to 30 megatons of TNT, leveling a city. The late catch exposed flaws in our survey network. Telescopes missed it earlier despite faint sightings, and algorithms failed to flag it as a threat. NASA's DART, or Double Asteroid Redirection Test, launched in 2021, tested deflection. On September 26, 2022, it smashed into Dimorphos, a 160-meter asteroid orbiting Didymos at 6.6 kilometers per second. This impact cut its orbit by 32 minutes, from 11 hours and 55 minutes to 11 hours and 23 minutes. This proved that a kinetic impactor can indeed shift an asteroid's path. For Apophis, a nudge years ahead, say 0.035 meters per second, could avert disaster. DART worked, but bigger, faster, or crumbly asteroids need more testing. Lasers and nukes are theoretical fixes. D-star lasers would vaporize an asteroid's surface for thrust, but we lack the power and space tech. Nuclear bombs could nudge via radiation pressure, not blasting. Fragmenting a rubble pile risks a debris swarm. A 2007 NASA study said nukes outmuscle kinetic hits 10 to 100 times, but launch risks and politics stall them. Neither's planned for Apophis, too untested. Apophis won't hit in 2029. It'll graze by letting missions like ESA's Ramses and NASA's OSIRIS-APEX study it up close. NEOs are plentiful and elusive, as 2019 OK's near miss proved. Scientists only caught it last minute, underscoring our blind spots. DART's a step forward, but lasers and nukes lag. The Torino scale keeps us honest. We're building defenses, but 2019 OK shows we must stay sharp. Space doesn't wait. Thanks for watching, and don't forget to like, subscribe, and hit that notification bell for more cosmic adventures. Until next time, keep looking up.